Welcome back to Calculus 1. Here we're working on problem number 20 from homework set number 4, portion 2. The solution to this problem is from -4 to +6, not including -4 or +6. So let's go ahead and see how we get that value.
For problem number 20, you're asked to determine all the x values that can make this setup be true. Now, it's not easy to find those x values. So what we're going to do is, instead of just trying to apply some rule, we're going to go through and try to think about what each of the individual pieces are saying and use some logic to figure out when this is less than 10. Now, another way to do it is also to graph it out, and you'll see that when we graph it, it becomes very clear what the values are. Okay, so let's go ahead and take a look at these guys. What would be nice is to just drop the absolute value portions. We can't do that because we don't know whether the thing on the inside is positive or negative or 0, right? So we can't just drop those values, these absolute values here. Okay, so let's take a look at some of the intervals in which these guys are positive or negative. Okay, so I'm going to look at a number line here. Now what if I picked a value that was, say, let's grab the number, I'll grab the number 4. Once I grab the number 4 for x, remember these are our x values. If I plugged in 4 here, this guy would become 0, which means that I could lose the absolute value. This guy would become positive, which means I could lose the absolute value. You see, because it's 4 plus 2 is 6, and the absolute value of 6 is clearly positive, so we don't need the absolute value. So for anything that's above 4, I'm cool with dropping the absolute values on both of these. So watch. X minus 4 plus x plus 2. This guy over here, both of these, this set and this set, both become positive when my x value is in that range. Okay? So there's absolutely no reason that I can't simplify it like this over here. So I'm going to get 2x minus 2. Now we need this guy to be less than 10, so let's go ahead and solve this. So this would be 2x is less than 12, or x has to be strictly less than 6. So here's 6. So here's what I mean. If you grab any number between 4 and 6, anything on this interval, it'll work. For example, let's grab the number 5. Let's just test this. This would be the absolute value of 5 minus 4 plus the absolute value of 5 plus 2. Let's check to make sure that that's less than 10. So this is the absolute value of 1. This is the absolute value of 7. And this is 1 plus 7, and that's clearly less than 10. So 5 works. In fact, you should pause the video and try another number on this range and see if it works. I guarantee you it will. Okay. Now again, how do we go through the logic of that? Well, we said that I grabbed 4 because I knew that 4 would make this guy not negative, and it also made this guy not negative. So let's look at another one in here that might make them both negative. Okay, so we looked at an interval where they are both positive. That's this interval right up here. Now let's look at an interval where both of these guys are negative. Well, clearly anything from 4 or less will make this guy negative, and anything from -2 or less will make this guy negative. So if I go -2 or less this way, then both these guys should be negative. Watch. Let's grab a number over here like, let's say, -3. Then it'd be the absolute value of -3 minus 4 plus the absolute value of -3 plus 2. So this would be the absolute value of negative 7 plus the absolute value of negative 1. So this is 7 plus 1, and that's less than 10. Okay, so notice that the insides became negative for both of these things over on this side. So what that means is that over here, since both of these are negative, they're both equal. The absolute values of them are equal to the opposites. Just using the definition of absolute value. Now we want those guys to be less than 10. So this would be negative x plus 4 minus x minus 2 is less than 10. So negative 2x plus 2 is less than 10. So we'll move the 2 over, so negative 2x is less than 8, or x is greater than negative 4. So that's our other endpoint over here. Okay, so anything between negative 4 and 2 will work. Now let's test to see if there's any issues in the middle. Well, if we grab a number like 0, and I plug in 0, I get negative 4 plus 2. That's less than 10. If I grab another number, and actually, by the way, we can do the following. We know that on this interval, this guy is negative, and this guy is positive. Think about it. If you grab a guy in this interval, like 0, 0 minus 4, that's negative, negative 4. And 0 plus 2, that's positive. So on this inside interval right here, this guy is equal to negative x minus 4, and this guy is equal to the positive version of it. So we can get rid of the absolute value signs here because this guy's positive, and when we get rid of the absolute value signs here because it's negative, we have to put the negative out front. So that's on this interval in between. So that'll be negative x plus 4 plus x plus 2 is less than 10. Now watch what happens here. Negative x plus x is 0. Plus 6 is less than 10. So 6 is less than 10. And you might say, well, but what about x? Well, the thing is that this came out to be a true statement. So anything in here will always be less than 10. In fact, anything in here will have a height value of 6. You'll notice that when we look at the graph. So these guys all work in here. These guys work here. Excuse me. And these guys work over here. So what does that tell you? That tells you that the x values that work have to be between negative 4 and positive 6. So our interval is from negative 4 to positive 6. Now let's go ahead and take a look at the graph. And this is what's interesting, is if you just graph this guy out, okay, here's the graph of the absolute value of x minus 4 plus the absolute value of x plus 2. Okay, it's got this strange graph. Notice that in between, here, let me get to the settings here. Let me bold this guy out. In between negative 2 and positive 4, let me go back to this. In between negative 2 and positive 4, we said that the height was always 6. Look at that. The height's always 6. We said from 4 to 6, our line should still be below 10. Let me graph the line 10 in here. Okay, so there's the height value of 10. So at negative 4 to positive 6, not including positive 6, we are below 10. We're below 10 all over here, and we're still below 10 until we hit negative 4. So from negative 4 to positive 6, we're below a height value of 10. From negative 4 to positive 6, we are strictly less than 10. And that's it. So look here, we didn't really have to know any rules except for what the absolute value function tells us, and we just had to logically go through the sections and say, okay, what about this interval? Which one of these guys up here, which one of these guys is going to be positive, which one's going to be negative? Are they both going to be positive? Are they both going to be negative? And then from there, we just use the absolute value properties. Pretty cool.